Okay, good morning to all. So now in this video we are going to discuss about the depletion mode MOSFET construction and working. So and the type of MOSFET, that is PMOS and NMOS. So in previous session we are completely learn about what is a MOSFET. So what are the types of in MOSFET. So the modes of operation of these MOSFETs and the symbols and the working of MOSFET. So the MOSFET is a metal oxide semiconductor device. So this metal oxide semiconductor device having the two types, that is NMOS and PMOS, along with CMOS also. So these NMOS PMOS transistors will be operated either in enhancement mode or a depletion mode. So now in this video we are going to discuss about the depletion mode MOSFET. So in this depletion mode of MOSFET, first we are going for the construction part. So in case of depletion mode MOSFET, okay, so this is equal to our construction part of a depletion mode. So here we can consider the substrate, so already we know this type of construction. So the depletion mode MOSFET operation is similar to the JFET operation. So here we can consider, so this is equal to the p-type substrate. So due to this p-type substrate we can consider the source and drain will be equal to the heavily doped region, that is equal to N region. This is equal to our source terminal, this will be equal to the drain. So the source and drain will be operated in heavily doped region, that is equal to the N plus region. So in between we can create a channel, so that channel will be equal to the N channel. So that's why depends upon the channel, this is equal to the NMOS depletion mode MOSFET. The channel here is equal to N. So that's why the type of transistor MOSFET is equal to the depletion mode MOSFET. In case of depletion mode MOSFET, so there is, when VGS equal to the 0, then there is a some finite amount of the channel will be provided in between source and gate. So that's why the channel here is equal to N channel. So this channel will be permanently existed during the operation of the depletion mode MOSFET. So next, other terminal of this MOSFET is equal to the gate. In between gate and the channel, so there is a silicon dioxide layer. This cross lines will indicate the silicon dioxide layer. So entire channel will be equal to our gate terminal. The entire channel length will be equal to our gate. So next, at the end, so we can provide the source and drain. So the source and drain will be provide the N-doped region, that is heavily doped region. So near upon which we can make some metal contacts. From this metal contacts we are for the terminals. Those terminals will be equal to the drain and source and gate terminals. So here the substrate equal to the p-type substrate. So the substrate will be equal to the, we can denote it with SS. So substrate. So this is equal to our construction and depletion mode MOSFET. That means the drain and source lets connect to the N-doped regions. The drain and source lets are connected to the N-doped regions. These N-doped regions are connected via an N channel. That means the source and drain will be connected via a channel. This N channel is connected to the gate via a thin insulating layer of SiO2. So the N-doped material lies on a p-doped substrate that may have an additional terminal connection called substrate. Okay, so that means here this N region and P region, these two are connected via a channel. Next, the gate will be provided in between the, so the gate layer is upon the silicon dioxide layer. So next, along with, so there is a p-type substrate. The contact with the p-type substrate will be equal to the additional contact, that will be called as substrate. This is the construction of a depletion mode NMOS transistor. Depletion mode NMOS transistor. Why it is called as NMOS means the channel here is equal to the N. So that's why the type of channel is equal to the N channel. Next, now go for the operation. The basic operation of this and depletion mode NMOS transistor. Here a depletion mode may be biased to operated in two modes. In case of depletion mode MOSFET, it will be operated in two modes, that is depletion mode or the enhancement mode of operation. Again, this depletion mode transistor will be operated in depletion mode and the enhancement mode of operation. These are the characteristics of the depletion mode MOSFET. So here is equal to the transfer characteristics of this depletion mode MOSFET is similar to the JFET in depletion mode operation. In depletion mode of operation, when VGS equal to 0, when VGS equal to 0, then ID equal to IDSS, then ID equal to IDSS. So here is equal to VGS equal to 0 and VGS equal to some positive values and VGS equal to the some negative values. So here is equal to in case of transfer characteristics, when VGS equal to 0, then VGS equal to 0, then ID equal to IDSS, and VGS equal to less than 0 volt, that means negative voltages, then ID will be lost, that means ID will be decreases. When VGS equal to greater than 0, that is positive values, ID is greater than IDSS. So the formula used to plot the transfer curve is ID equal to IDSS into 1 minus VGS by VP whole square. So that means here the transfer characteristics of the depletion mode of transfer depletion mode NMOS transistor is similar to the JFET. So that is, let's go for the transfer characteristics of in depletion mode when VGS equal to 0. So this is equal to, so this line will be equal to the VGS equal to 0 line. So that means when VGS equal to 0, then ID equal to IDSS, that means you can get the maximum current. When VGS equal to less than 0 means negative values of VGS, that is -1, -2, -3 and so on, then the ID value will be decreases, IDS value will be decreases, ID value will be decreases. When VGS equal to the positive, that means greater than the 0 voltage, VGS equal to increases, VGS equal to the positive value, then ID will be increase greater than the IDSS. These are the three cases, that means simple way. So when VGS equal to 0, when VGS equal to 0 volts, then the current ID equal to maximum current, that is IDSS. When VGS equal to greater than 0, that is positive values of VGS, then IDSS will be increases, that means the ID will be increases, and VDS is less than 0, then ID will be decreases. These are the transfer characteristics of a depletion mode MOSFET. So the characteristics are similar to the JFET. So now drain characteristics of the depletion mode MOSFET here is, so when VGS equal to 0, you can get maximum value of current, that is equal to IDSS. When VGS is going to be negative, then the ID value will be decreases. ID value will be decreases up to some voltage. So when it is reaches to the VGS equal to VP, that will be called as pinch off voltage. So to calculate that, to draw the transfer curve, we are using the formula, that is equal to ID equal to IDSS into 1 minus VGS by VP whole square. These are the transfer characteristics of depletion mode MOSFET. So at the same time, MOSFET in enhancement mode of operation. So in this enhancement mode of operation, so in this mode, the transistor operated with VGS is greater than 0 and ID increases above the IDSS. So the Shockley's equation, the formula used to plot the transfer curve, still applies, but VGS is positive. ID equal to IDSS into 1 minus VGS by VP whole square. So that means in enhancement mode of, in MOSFET in enhancement mode, so here we can draw the transfer characteristics only for VGS equal to VGS is greater than 0. When VGS is greater than 0, then ID, that is drain current, will be increases above the IDSS value. So according to the Shockley's equation, again we can plot the transfer curve, that is ID equal to IDSS into 1 minus VGS by VP whole square. So this is equal to the depletion MOSFET in enhancement mode operation and depletion mode of operation. In case of depletion mode of operation, VGS equal to, there is three cases, that is VGS equal to 0, VGS is less than 0 and VGS is greater than 0. In case of enhancement mode, there is no negative values of VGS. So VGS equal to 0 or VGS is greater than 0. When VGS equal to 0, we can get the maximum current, that is IDSS, ID equal to IDSS. When VGS is greater than 0, then so the drain current will be increases. These are the D MOSFET operated in depletion mode and enhancement mode. So when we are considering P channel depletion mode of operation. So in case of P channel depletion mode of operation, again the construction of this P channel depletion mode operation is similar to the N channel depletion mode MOSFET. The only difference occur here is, so in case of construction part, so here is equal to the P channel, so that's we can consider N type substrate. Again, due to the P-type or PMOS and PMOS transistor, you can consider source and drain is equal to the heavily doped P regions. So the source and drain will be equal to the heavily doped P regions. So in between source and drain, we can create a channel, that is permanent channel is in between source and drain. The channel will be equal to the P channel. So upon this P channel, so upon these terminals we can provide the silicon dioxide layer, that is acts as a insulating layer. So during entire the channel width or channel length we can provide the gate terminal. So that means here, so P heavily doped P regions will be indicate the two terminals, those are source and drain. In between these two we can create a channel. So upon this channel we can provide silicon dioxide layer, and upon this silicon dioxide layer, we can provide the metal contacts. So the metal contacts will be related to the three terminals, that is source, drain and gate. So other extra terminal, additional terminal here is equal to the substrate terminal. Here the substrate will be equal to the N type of substrate. So this is about the P channel construction. The only difference occur between the N channel and P channel is, so in case of N MOSFET, we can provide the source and drain is also heavily doped N regions. In case of PMOS, the source and drain will be equal to the heavily doped P regions. So in between these two regions, that is source and drain, we can provide the channel. That channel will be equal to the same. That is, in case of N plus region, the channel is also N. In case of P plus region, the channel is also P. So the opposite one will be equal to the our substrate. In case of P plus region, the substrate equal to the N type of substrate. So other terminal will be extra additional terminal will be equal to substrate, that will be called as SS. That is equal to the PMOS construction. So that means look at this. So the P channel depletion mode MOSFET is similar to the N channel, except that the voltage polarities and current directions are reversed. That means except that, so the voltage polarities and the current directions are reversed in case of PMOS and the NMOS. Again, so we go for the P channel depletion mode of operation. We go for the transfer characteristics and the drain characteristics. So in case of this PMOS MOSFET, so these are the transfer characteristics. So when VGS equal to 0, so the value of ID equal to the IDSS. When VGS equal to the negative, so when VGS equal to 0, then we can get the maximum value, that is IDSS, ID equal to IDSS. When VGS equal to positive, that is VGS is greater than 0, then ID will be decreases. When VGS equal to the negative, the ID will be increases. That is complete opposite operation or reverse operation of the NMOS. In case of NMOS, when VGS equal to 0, then ID equal to IDSS. When VGS is greater than 0, then ID will be increases. So when VGS is less than 0, then ID will be decreases. That is the NMOS. In case of PMOS, when VGS equal to 0, ID equal to IDSS only. When VGS is greater than 0, positive values, then ID will be decreases. So next, when VGS is less than 0, ID will be increases. These are the transfer characteristics of PMOS transistor. So at the same time, the drain characteristics of this PMOS transistor is when VGS equal to 0, then ID equal to IDSS. When VGS will be increased in positive direction, then ID will be decreases. Then ID will be decreased. Just like when VGS is increased in positive direction, then ID will be decreases. So these are the transfer characteristics and drain characteristics of PMOS transistor. So this completely discussion about the D-MOSFET. So D-MOSFET means depletion MOSFET. It will be again operated in depletion mode and enhancement mode. So now go for the other type is equal to enhancement mode of MOSFETs. So now go for the enhancement mode of MOSFET construction. So in this enhancement mode of operation, again we go for the NMOS. So that's why the substrate here we are using the P-type substrate. So due to the NMOS, so the source and drain regions are heavily doped with N regions. So upon this we can provide the silicon dioxide layer. So the entire channel will be equal to our gate. So from this we can provide a metallic contacts. So those metallic contacts got the 3 terminals. Those are the gate, source and drain. So next other additional terminal here is equal to the substrate terminal. So but in enhancement mode, so the only difference between depletion mode and enhancement mode here is, in case of depletion mode, so there will be a channel will be existed, but in case of enhancement mode of transistors, there is no channel will be provided. That means you can create a temporary channel. So that's why here there is no channel in between. There is no channel in between source to the drain. In case of depletion mode, you can provide the channel. The channel type is equal to the N channel. So but by applying the voltages to the gate and voltage to the in between in between drain and source, depending on that we can provide the channel. So this channel will be temporarily existed between the source and drain in case of enhancement mode, but the channel will be existed the channel will be existed permanently in case of depletion mode of operation. So now we are going to study about the enhancement mode. So in this enhancement mode of operation, so the drain and source connected to the N-doped regions. These N-doped regions are not connected via an N channel without an external voltage. So the gate G connects to the P-doped substrate via a thin insulating layer of SiO2. The N-doped material lies on a P-doped substrate that may have an additional terminal connection called SS, that is substrate connection. The N-doped material lies on a P-doped substrate that may have an additional terminal connection called the substrate. This is the construction of enhancement mode of transistor. So the drain and source are connected to the N-doped regions. These N-doped regions are connected via an N channel without an external voltage. The gate connected to the P-doped substrate via the thin layer, that is thin insulating layer of silicon dioxide layer. The N-doped material lies on a P-doped substrate that may have an additional terminal connection called the SS. So now go for the enhancement mode MOSFET symbols, that is N channel and P channel. Sorry, here we will go for only N channel symbol. So here N channel means that will be indicated by the arrow mark is in inward direction. When the substrate and source will be connected, you can join the terminals of source and substrate connections. These are the symbols of E-MOSFET symbols, that is N channel or a NMOS. So now go for the basic operation of this NMOS. For the basic operation of these NMOS, enhancement mode transistor. In enhancement mode, MOSFET only operates as in the enhancement mode only. So in case of depletion mode MOSFET, it will be operated in depletion mode as well as the enhancement mode. But in case of enhancement mode of MOSFETs, these are operated only in enhancement mode only. So here is equal to VGS is always positive. That means it is not operated in negative region or a negative applied voltage. So when VGS is always positive, then IDS is equal to 0 when VGS is less than VT. that means less than threshold voltage. So when VGS is less than VT, suppose this is equal to our VGS line, this is equal to ID. So when VGS is less than VT, that means this region, so then ID equal to 0. As VGS increases above the threshold value, then ID will be increases, ID value will be increases. If VGS is kept constant and VDS is increased, then ID saturated. The saturation level, VD saturation is reached. So that means here we go for the transfer characteristics of this enhancement mode MOSFET. When VGS equal to 0, or when VGS equal to, okay, sorry, so when VGS equal to 0, when VGS is less than VT, the value of ID equal to 0. When VGS increases in positive direction, the ID will be increases. When VGS will be increases, then ID will be increases. At the same time, when VDS will be increases, then when VDS is increased, then ID is in saturated. That is, the saturation level is equal to IDSS. That means which will maintain the constant value. When we are increasing the VDS value, so which maintains the constant current. Simply, when VGS equal to some 0, ID equal to 0. When VGS equal to the increases, so that is VGS equal to 3, 4, 5, 6 and so on increases, ID is also increases, ID value will be increases. So once the ID value will be increases, then VDS value increases, then VDS value will be increases, then which will maintain the ID value as constant. ID value will be equal to the constant. This constant value of ID will be is in saturation level. That means, so when we are increasing the VDS, the ID will be maintained constant. So the constant ID will be is equal to our saturation current, or the level will be called as saturation level. That means in enhancement mode of operation, so when VGS is less than VT, VGS is less than threshold voltage, then ID value equal to 0. ID value equal to 0 or IDS is equal to 0. When VGS value will be increases in positive direction, or positive means, so greater than VGS equal to VT, then ID will be increases. So next, when we are increasing the VDS, so the ID will be maintains constant current. This constant current will be called as saturation current. This is the transfer characteristics of a enhancement mode MOSFET. So again, to determine the or to draw the plot of the transfer curve of the MOSFET, we are using the formula ID equal to K into VGS minus VT whole square, where K is equal to ID on by VGS on minus VT whole square, where VT is the threshold voltage or voltage at which the MOSFET turns on. K is equal to the constant found in the specification sheet. Okay, to plot the transfer curve of a MOSFET, we can use the formula ID equal to K into VGS minus VT whole square, where K equal to ID on by VGS on minus VT whole square. Here VT is the threshold voltage, K is equal to the some constant value. So this is about the enhancement mode of NMOS transistor. Next, go for the P-channel enhancement mode of MOSFET. So in case of P-channel enhancement mode MOSFET is similar to the N-channel, except that the voltage polarities and current directions are reversed. That means in case of N-channel, so when VGS equal to, when VGS is less than VT, the ID will be equal to 0. So here also when VGS is less than VT, so VGS is greater than Vt, the ID value will be equal to 0. When VGS will be increasing in negative direction, the ID will be decreases. So just the difference between PMOS and NMOS enhancement MOSFET is, so their polarities will be voltage polarities and current directions are reversed. At the same time, look at the construction of this PMOS transistor in enhancement mode. So in this PMOS enhancement mode, so we can consider n-type substrate. Again, source and drain will be related to the heavily doped region because PMOS, that's why the regions are P regions. So there is no channel existed between drain to the source or source to the drain. So uh, the gate terminal is provided for the substrate to the silicon dioxide layer. So upon the silicon dioxide layer, you can provide the metal contacts. These metal contacts will be related to the gate terminal. Then heavily doped P regions will be equal to the drain and source. The additional terminal will be equal to the substrate. So next, the transfer characteristics are the transfer curve of these PMOS enhancement mode transistor here is when VGS equal to VT equal to minus 2 volts, then the ID will be increases. So when VDS will be decreases in negative direction, the ID will be increases. That is completely reverse operation of the N MOSFET. In case of N MOSFET, so when VGS is less than VT, ID equal to 0. So in this case, when VGS is greater than VT, then ID equal to 0. So next, when VGS will be increases in positive direction, the ID will be increases. Here, when VGS will be increases in negative direction, so the VGS will be increasing in negative direction, the ID will be increased. So at the same time, when we are increasing the VDS, so the ID will be maintain constant value. So this constant value will be equal to our saturated region. So that region will be called as saturation level where the ID will be maintained constant. So these are the transfer curve of a P channel in case of enhancement mode of operation. So now the total summary of this JFET, depletion mode MOSFET and enhancement mode of operation. So look at this. First go for the symbols. So the symbols of JFET is equal to the again. So these transistor having 3 terminal gate, drain and source. So when you are adding a substrate, you can add the extra additional terminal that will be equal to the SS. So here is equal to all will be indicates the N type. So in case of N channel, JFET or depletion mode MOSFET or E channel E MOSFET, the arrow mark is inward direction. Again, to plot the graph, you can use the formula ID equal to IDSS into 1 minus VGS by VP whole square. So that is similar, the JFET operation is similar to the D MOSFET. So in case of E MOSFET, ID equal to K into VGS minus VP whole square. So next here is equal to when you draw the transfer curves of these JFET, depletion mode and enhancement mode of MOSFET. So the similar characteristics between JFET and depletion mode when VGS equal to 0, when VGS equal to 0, ID equal to the IDSS, ID value equal to the maximum value. So when we are increasing the VGS, in negative direction, then ID will be decreases from the maximum value to the pinch of voltage. So next, in case of enhancement mode operation, there is no negative operation of VGS when VGS is less than threshold voltage, that is VT. VGS is less than threshold voltage, ID equal to 0. We are increasing the VGS value greater than threshold value, the ID value will be increases. This is the operations of, so the complete summary of the JFET, depletion D MOSFET and enhancement mode of MOSFET. So that means the only difference between D MOSFET and enhancement mode MOSFET is, in case of D MOSFET, it will be operated in 2 modes, that is depletion mode and enhancement mode. But in case of enhancement mode transistor or MOSFET, it will be operated only in enhancement mode only, and that is only positive values. So this is the complete operation of the MOSFET. So MOSFET, so their type and their working conditions. So the MOSFET will be having two types, NMOS and PMOS. These will be operated in depletion mode and enhancement mode. In depletion mode, it will be operated in two modes, that is depletion and enhancement mode. But in case of NE MOSFET, it will be operated only in enhancement mode only. That is, it is not operated in negative values of VGS. Thank you.